Hello, hello, welcome back everybody. Welcome to our Clipper compiler series in Clipper. Today we're going to pick it off from where we stopped last time. But before we get into it, I wanted to address a couple of things. So I was taking a look at the comment section of my last video, and I noticed this one here from Frosty. So if you're watching this one, thank you for watching, Frosty, and hi there. So he was asking about why my syntax highlighting is so lacking in color. And I think it's a fair point because up until the last video or the one before it, I was using Capuchin like 90% of NeoVim users, and I was kind of bored of that theme, and I ended up going into this website here where you have a lot of different color schemes, and the default view is the trending color schemes. And I was browsing this and looking at different ones. I used to use Tokyo Night, by the way, and then I moved to Capuchin. Mocha, I think, is the darkest one. Yeah, and then I tried Kanagawa, Groovebox, especially Groovebox. I thought it was too colorful, and maybe because I'm colorblind, the amount of red, or I don't even know if this orange or red, but the amount of the color bothered me, especially with the Rust syntax. So I didn't go with that. And then I kept going, and I tried a couple more, and I landed on this guy here, Lackluster. And I found this was very interesting, mostly because of that. Like it's basically monochrome, but it plays a lot with different shades of gray, right? Then I was intrigued. And then I went to the Git repo, and I saw this, and I said, you know what? This looks good. And I saw that it had support for Lua and whatnot. So, you know, to long story short, I liked it. And so what I did is I applied that to my Vim. So if we go to, let's go here to assembler.rs. This is what it looks like. So the strings are a little bit, the strings have a little bit of a call out. But outside of that, everything else, like if you have errors here, like this, it's pretty nice. I think red here is very suitable. But other than that, you know, everything is shades of gray. And I like it. To be honest, I like it a lot. I like it so much that I customized Tmux to have the same look and feel. And I also made my terminal. My terminal is a lot more colorful, but I transitioned it from Capuchin to something more sober with this black background as well. And for me, it worked. So if you guys are like Frosty, you don't like it, or you think you lose a lot for not having the syntax highlighting be a little more colorful, please let me know in the comments. I'm open to try another theme. Just wanted to get that out of the way because I think the comment made sense. Like people can be that are not used to Rust or are learning Rust, maybe they don't feel comfortable or they're threw off by this color theme. So let me know what you think about it. Now talking a little bit about where we left off last time, if you guys remember, we started doing calling functions, and we came up with this standard library here where we had the error level that is called by our assembler, so assembly. If I do cargo run, this is going to generate test.s, and if I try to compile test.s with our standard library and we run a.out, you can see that we do get status of 2. One thing I didn't do last time that I think is beneficial for us to see is if I go to main and I change the variable 1 and var1 to like 72 or something crazy like this, you see that if we run this again, I need to do cargo run, then compile, and then do test.a.out, and we check the status. You can see that it's now 72, right? So we are indeed compiling this program, if you had doubts about it, right? All right, let's put it back to 2. And then one thing we attempted to do last time, we went to our standard library, and we tried to do a println here with error level, and then let me turn off Copilot, disable. Yeah, and then we tried, so if I rebuild the standard library and I try to link it, it's gonna link, but then when I try to run it, we get this this error, right? And the thing that I want you to pay attention is this message here, address boundary error, right? Why are we getting this, right? Why did this work with exit, and why it doesn't work anymore now that we have println added to the code? And I know that a lot of you guys know about this already, but for the benefit of people that don't know, there is, I want to say, a contract between languages when you're calling other languages from your language. And I think the prominent language here that we're talking is C. But a lot of other languages follows what it's called ABI of the language, right? And it's all about the calling conventions and other conventions that you have on how you manipulate the stack and registers in a way that you're talking the same language. The caller, like here our code, if we go to main.s, right? Let me go here to main.s, not test.s. So we are the callers because we are calling error level, right? And the callee is error level. So if we go back here to lib.rs, this is the callee, right? The function that is being called. So we, as the caller, we are using assembly, and the callee is using Rust, right? Just to make sure that we have the same addresses, the same register contracts. People came up with this ABI thing. So if we go here to OS dev, you'll see that we have a reference to the system V ABI, right? And the thing that is making our program fail is because we need to align the stack. Basically, we need to make sure that the stack is at a point where it is a multiple of 16, right? Because you can increase the stack pointer by other factors. You can increase it by 1 byte, you can increase it by 8 bytes, it doesn't matter, right? And we are, in fact, not following this convention, and that's why it's failing. So in order to fix that, all we need to do is to align our stack when we call a function from other languages. But we're going to do that for all the calls that we have, right? So keeping this information in mind, it would be nice for us to go back and try to add this alignment to our existing program first to see if we can make it work. And in order to do that, I'm going to try to align the stack to the nearest multiple of 16 from what we have right now. So since we're only doing 2 allocations here, we're using, I think, 8 bytes of the stack. So all we need to do, theoretically, is subq, and then 16 from RSP, like this. Let's see if that makes any difference in our program that we already have. So let's do it like this. Let's build. No, sorry. It's just this and a.out. And as you can see, it still doesn't work. And that's because we are not even setting the stack pointer and the stack base frame pointer to the entry point of our function. In order to do that, we need to go and do pushq RBP. We're going to save it to the stack. And then we need to do a movq of, sorry, this is %sign here. And we have to do move the stack pointer to the base pointer, like this. Now let's try this again. And you can see it works, right? So if we look at standard lib.rs, this works. So we can change this to hello world. And if we compile this again with cargo build, and then we link it again, we can see hello world 72. Isn't that cool? So now all we have to do is to retrofit what we manually added here to our program, right? Let's try and do that. Let's go to assembler, and let's add first the 2 lines that we had, those 2 lines, right? I think this is called the function prologue. I never know how to pronounce that, but it's what I'm trying to say is this. Prologue, I think it is, like this. So let's go to the place where we start the main function. So here, and we're going to write ln this, and then pushq RBP, like this, and write ln f, and then movq RSP into RBP. Like this. So this was pretty easy. The other thing that we need to do is keep tabs on how much of stack we're using, right? So if we go back to the test.s example, we need to keep track of this offset here that we're using for our program, or specifically for this subroutine here. And we're going to see that when we start creating subroutines within our code, right? Right now, we're only calling external subroutines. So let's go to the replace sudo registers, and you will see that we are already tracking the size of the stack on this offset. It's just negative, right? So what I think we can do is we can, after we have the instructions that we're going to call, we're going to have another new instructions vector. So this is going to be a vec new. And then we're going to prepend the instructions. So new instructions. Oh, before we do that, we have to make sure that we are aligned by 16. And the way I like to do it is to do the following. So let aligned stack space is going to be the minus offset, right? We make it positive, plus 15. So the one value below the alignment that we're looking for, divided by 16 times 16, right? Basically, this is going to make, since this is an integer division, everything between 0 or 1 and 16 is going to be divided. So 1 plus 15 is going to make 16. Divided by 16 is going to be 1. So 1 times that. And then if we go beyond 16, it's going to be, let's say, 17, right? It's going to be 17 plus 15. So I think 32 divided by 16 is 2 times 16, 32, right? So I think this is a pretty good way to achieve that. And then we need to do the prefixing. So new instructions dot push. And here we're going to have a new instructions that's going to be responsible for doing this, right? So let's go ahead and push. It's going to be instruction, align, stack, or locate, stack, and then aligned stack space, like this. Then we're going to add, so new instructions dot extend instructions, like this. And then new instructions dot push, because something we didn't do here at the end is to do a add queue 16 to RSP. So we restore where we were before executing our subroutine, right? So let's make sure we also do that. So it's going to be instructions, delocate stack, aligned stack space, like this. We don't have those. Let's create them. Let's create allocate first. Oops. Generate variant, same thing here. Then one thing we can do here is to call this temporary instructions. This way we can rename this guy to just instructions. And then here we extend temporary instructions like this. This way we already have a nice name to add it to program here. And I think that's it. Oh, we forgot to implement the allocate and delocate. So here, let's do the following and fill match arms. So allocate stack, it's going to be like the offset. And we're going to do, oops, right F, and then sub Q, tab again, then the amount. It's going to be, yeah, offset, and then RSP or RBP. Never remember. RSP. Like so, right? And what's wrong here? Why is it complaining? I don't know. We're going to figure out soon enough. Let's add offset here again. Let's copy this. So yank to comma. Then we're going to go down here. We're going to select to comma and hit paste. Oh, this didn't work, did it? So let's do yank everything. And let's do visual everything and then paste. There we go. And just here it's going to be add queue like this. And I think we should be good. So now let's try to do cargo run. We generated our new program here. You can see that I don't see. Oh, here it is. Sub queue 16 and then add queue 16. Let's make sure that we can run it. Let's do GCC like that. Let's do a.out. And there we go. Hello world 2. There are two more things that I want to do. Basically, I want to go back to where we had main. And since we're pushing this to RBP, it makes us a good citizen if we revert that with popq, I think. Yeah, popq. So we take it out of the stack. And it's a nice thing to end subroutines with ret as well. So we're going to add that too. And later on, when we support subroutines, we're going to have the ret instruction and probably pop. And this, as I said, this is the function prologue. This is the function epilogue. Maybe I'm butchering this name, not sure, but it's what happens after every function. All right, so just to make sure that we're still compiling, let's do cargo run with our new oh, and we forgot a tab here. Let's do that again. Let's link it. And there we have it, still works. Now to make our lives easier, let's go here back to main so that we don't have to run GCC every time, right? Let's make sure that we have a final command here after we write our assembly file. We're going to do compile program. Let's pass program like this. Let's create a method. So function compile, and then this is going to be the program, and this is I think assembler program. That's right. So this is going to be an assembler program. And of course, the first thing we need to do is what we were doing before, like this, and this can fail. So we're going to do anyhow result. We don't need to return anything. Just do an OK here. And this gets us to the point where we were before. So after that, we're going to have to call and run the same command that we have here. Let's see if I remember how to do that. So it's going to be command dot, and then run, no, new. And what does new takes? Let's see. Yeah, like that. So it's going to be GCC. And then I think we add arguments. So we're going to do, we're going to output it to, let's create so lat file name equals. It would be nice for us to receive the name of the file, but I'm not going to do that just a second. So we're going to do ergo dot, it's going to be our asm file. And then we need to do, can we do, yeah, I think we need to split this like that, then arg minus L target debug like this, dot arg minus L dot arg your standard lib like this, dot run, start execute exec, maybe we'll figure it out. As value, we don't have it, that's right. Let as file equals, I know that there's something like this, like path new file name dot with extension or something like that. Let's see. Rust path with extension. Let's see, extension. Do we have with extension? Here it is. Yeah, so I think that should work. Let's see. So let's import path. And then here it's going to be output. Oh, and that's not an ASM file. That's our output file. And that's actually the executable. So let's, sorry about that. Executable. It's going to be that with no extension. So we do with extension nothing. And I think this is not be safe to call after fork. Let's see here. Rust execute a command. So command.new args output expect. I like that. Let's see. So new arg, and then output, and then like this. Okay. And then if that works, we can remove test.s, right? Let's see. Rust delete a file. So it's going to be fs.remove file. File name. And here, file name as well. Like this, so we don't consume it. It doesn't allow me, so we will have, unfortunately, to clone here. It says it's redundant. What is the file name? Oh, it is already stir. Yeah, never mind. I got carried away here. All right, so now let's remove test.s. Let's do a cargo run. So if everything went according to plan, we should have a test, which we don't. So let me move o.out. Let's see it again. Test.s, okay. Let's get the output. So output equals to this. Let's print it out. I think we need to get the exit code. That's right. No, not here. Let's try it again. Rust command exit code. Exit. Status. Yeah. So let's do status. Let's print status. So, oh, what is the status? It's an exit status. Nice. So, status like this. Let's run. Aha. Nice. So, undefined reference to main. Why is that? No GCC. Oh yeah, we never tried to do the out thing. So did it keep test.s or did it delete it? I think it deleted it. Let's try once again. Cargo run. Status 256. Okay, let's print. So GCC -o test -l dot target dot debug -l yaw standard lib. we never gave it the source file, did we? I think it makes it a little more complicated if we don't do that. Yeah, so that's our first parameter even before that all. So let's do arg file name here. Cargo run. There we go, status 0. And we should have a test, and if we run the test, there it is, hello world 2, nice. And we don't have test.s anymore, so that's just an intermediary file, and our executable now compiles the file. So I think it would be nice to also take the source file name from as a parameter, right? And then we can read the file, compile it. Let's tackle that. In order to do the command line stuff, let's do clap. So if let's add clap, and I think for clap, yeah, I want derive. Cannot determine which package to modify. That's right, we have to go into core. There we go. And this, we may need serde and serde JSON to serialize our, maybe not, we'll see. Maybe just serde, we'll see. Let's play by ear here. So before main, let's create a struct args, and here we're gonna have name of source file to compile. So here we have source, and this is gonna be a path buff, I think. And this makes sure that this is a valid path. And this is gonna derive No, parser. Let's take a look. So clap.rs. Tutorial. Yeah, parser. The problem is that we already have a parser. Let's see here. So we need to use clap parser. Use clap parser as this. So if we here do clap parser like this, would this work? I think so. So now what is the command we call? I always forget. Parse, of course. So let CLI args parse. And then let program equals fs read to string. CLI dot source. Like this, and I think we may need, okay, that works. And we're gonna take this out. And we will have to borrow it. Okay, so let's do a cargo run. What do we get? Yeah, I need to take that. Yep, there we go, yo core source. So let's do cargo run, and that's how we have now we have to create a file. Let's see where we can put here. Let's add another folder called samples. Let's do basic.prg. PRG is the extension for Clipper. We should look if we have NVINIS and NeoVim dbase or something like that. The database client, database, let's see, Xbase. Not seeing, maybe we create one. NeoVim Clipper. Clipper integration for Vim. Is that the Clipper that we think it is? Cutting, streaming small pieces of thing. Yeah, this is not our Clipper. Okay. Yeah, I'm gonna do that offline. For now, it's fine if we just do cvar1 equals 2, and then error level cvar1 like this. All right, let's see. Cargo run, samples, basic.prg. We had an issue here. Yeah, of course, because we, let's see. So no such file or directory. Yeah, we're inside core, aren't we? Let's try it again. No such file or directory. We ended up, yeah. So let's move this out of samples. So if we go here and take core out, oops, I messed up. So you enter, there we go. So let's try this again. There we go. Exit status 0. So now it's still going to be called test, right? Yeah, let's fix that. So let's go to main. And what we can do is down here where we compile, instead we pass the args and the program. So args is going to be a reference to CLI, like that. Is it? Oh, it's CLI. It's the other way around. This is called CLI, and this is called args. Yeah. So file name is going to be, yeah, so, oops. It's going to be args.source.with extension s, like so. And so executable is going to be file name dot with extension. Clone. Let's see. Okay. We can do it like this. And now we're good. So let's see. So we have another partial move here. So let's see, where is it being moved? CLI. Oh yeah, we can reference it, make it a path instead of a path buff. And that should work now. Let's try it again. So we should have, I'm seeing we don't have it. I was expecting to have a sample.exe, so let's remove test. Let's see what we're doing wrong. So let's go to compile. So we're defining the files here. We're write the ASM file, link it, remove the temporary ASM file. Like this, and we're not doing anything with status, which I think we should. If status not equals 0 is success, I think so. Panic, error, linking, status. Okay. Let's see here. So file name, executable, this, cargo run. Ah, yeah, exit status. So if it's not a success, we panic. See now? Oh, samples. Yeah. That's why it's inside samples. Yeah, I think that makes sense. So let's do samples basic. Yeah, so I think we need to put a few messages here. So if it all succeeds, we can say something like compiled and then args.source. Is that correct? Oh, yeah, we can do that. Compiled something to something. And then we can do args.cli and executable. Standard buff. Sure. What is it? Oh, this guy. Doesn't this make it a path? This is a path buff. Okay, thought it made it to dot as path to stir and wrap as path to stir unwrap. No field CLI, yeah, of course. This is source. If we try to do it like this, does it work? It doesn't. Let's try it again. Yeah. Cargo run. There we go, compiled samples basic.prg to samples basic. All right. Let's do the following. Let's go back to our standard library. Let's take this out since this is not really what we wanted to do. Let's create some integrated tests. I think it's a good idea to have like a test suite that we can use. So let's do core tests. No, not like that. Like this. And let's add exit code.prg or error level. And we can do something like integrate it, right? And then what we can do here is do a test, call it integrated tests, and we can check all the PRG files in this folder, get a list of all PRG files in this folder, compare exit code to the expected. So what we can do is, let's do this, and then when we go to PRG, let's get the basic here, put it on the error level, like this. And maybe we can have, so comments in Clipper are we handling comments? I don't think we are, because I was going to suggest, let's see here. Let me open my Clipper book that I have, 1 second. So yeah, here. So yeah, here you can see, let's find it again. Comments. Yeah, this is for a make utility. Yeah, so you can see that comments are like C. So what I was thinking is we should add like something like exit code expected to, something like this. Then we could parse this and extract what it expects. So let's go on a side quest here and go to our Lexer and make sure that we have the / thing. So let's create a new token here. Strum props regex r. So what it's gonna be 1 2 maybe, not sure. And then double slash. That's a we need a / like this for comments. Let's see if that works. So we can create a test here. So config test mod tests, use superstar, then /. So let program equals comment, and then some cvar1, because this is nvar, then inline comment. We need this guy, I think. Then let Lexer new program. Let tokens equals Lexer dot tokenize. Yes. Unwrap. Not expect. Assert equals tokens. What do we expect here? Let's see, a vec. So it should be /. Yeah, then I think we should completely ignore this, right? Yeah, we need to ignore if it's a /. So nope, nothing here. We just expect an identifier and var. Then we expect that colon equal. And we expect an int 1. That's it. All the comments shall be ignored. This is token. This is token. This is also token. There we go. There's an issue here. Expected string found stir. Okay. To string. Perfect. Cannot. Yeah, this guy has to be mutable. Tracks the position of the tokens. And this is indeed a test. Let's see. Oops. Let's see this test fail. So let's run it. It failed. Let me remember how I opened the. No, it's not like that. So let's, yeah, so hold on. Let's go back to running it side by side. If we do cargo test, this should fail. Panic unexpected token. There we go. All right, let's take it from there. So we push it here. So what I'm thinking is let's keep the token here. Not sure if that's the best way, but that's what I'm gonna do for now at least. So /, like this. And I'm thinking here that if we support comments, we're going to have to make new lines be a token as well. Because, yeah, we don't have a terminator like a semicolon. So if we just keep parsing, unless we have, thinking here. I think we can have a special thing for parsing comments. Like we have for our white spaces. I think that might be worth doing. Let's see. If let sum ch equals self.source.chars .nth self pause, then we do if ch is a forward slash, then if let sum ch equals self.source.chars .nth self dot pause plus 1, then if ch equals this, then we need to eat everything until no line, while self dot, if we are here, we can already do self dot pause plus equals 2, while self dot source dot chars dot nth self dot pause not equals new line. We do self dot pause plus equals 1 if self dot soar dot chars dot len minus less than self dot pause break. I think this is a lot better if we do it like if the position is more than self.source.chars.len, we break. Yeah, we don't need this. Just len is fine. Okay. Expected object. Yeah. Sum is fine. Let's run our little test here. Yeah, let's test this. Oh yeah, this is another test, unrelated, I think. Let's see. Cargo test, double slash no capture. Oh yeah, unexpected token. We need to debug this. Let's see. Skip comments. So let's see. Next char is gonna be this self source chars and self.pause was a slash. Next is self source chars and self.pause plus 1. Need to take out this guy. We go. Do it like this, both there and here. println was another slash eating until new line. Oh, hold on. Yeah. Was another slash. So 1, 2 here. Pause equals. Pause. Self pause. Println new pause. Self pause. And we can do, oh, we already advanced 2, so we don't do it like this. We actually do it here. Self.pause plus equals 1. Okay. Let me think. I think we can do here while let sum ch equals this, because it will return none if we're passed. And that's going to make it a lot easier. Lead to this. Then if ch is a new line, break. Otherwise, keep going. I like that. Println found ch. Breaking. Can we do this like that so we can see the new line? Let's see. Breaking, nice, okay. So I think it worked, but you know, this thing worked, not the rest. So let's see. Oh, we need to consume the new line, right? Unexpected token. Where do we do that? Unexpected token. This indicates that we need to eat the comments before the white space, because the white space is the one that consumes the new line. Let's try it again. Did it work? Nope. But it went further. Yes. So very cool. But it did identify our comment. What? Let's see here. So was a slash. Next is some space. Space. So no. Let's see. Was a slash. Was a slash. To make it a little more sane, let's do the following. Self.pause plus 1. Then here, let's go to that plus and delete this. We do 1. Oh, this is looking for self.pause. Next is, that's fine. So /n. Yeah, it's an egg and chicken kind of problem. So let's revert it back. So what I think we need to do is actually eat the new line. And we keep the white space where it was. We go here. And it's as simple as self-pause plus 1. Then if it is a new line before breaking, we do self.pause plus 1. And we can leave the breaking here. Let's see, breaking. Unexpected token. Yeah, that's the space. Okay. How about, yeah, so we have to loop, right? Because we may have spaces. Okay, let's do the following again. Let's not eat that because we may have more white spaces, more new lines, right? What we need to do is to return here. So a Boolean saying if what the past of skip? Skip comment or not? So here, instead of breaking, we can actually return true, right? But if we did what we wanted to do and we didn't find that case, we want to return false. Okay, skip comments. So here, if skip comments, continue, right? And then we don't need this once again. Let's see, clear, breaking, next char. So found comment, no line, breaking, next char, okay. Was a slash after some n? I doubt it, my friend. Let's see. So this is actually here. This goes here. Okay, and it seemed like we just passed the test. So let's get rid of those print lines like this. Perfect. Okay, and then if we run this test again, yeah, it passes. Perfect. So now that we have comments, I think it's a good point for us to start taking a look at what we did. So, oops. Assembler. Yeah, we added the stack alignment stuff. This is comments, and this is, okay, so let's commit this. So feature stack alignment for sys V ABI on function calls. Let's see the Lexer. This is where we added the ability to, we left one print line here, and I missed that. Let's see any others, print line. Yeah. I thought I removed them all, but I guess not. I didn't pay attention when I should have. Do we have warnings? Yes. So let's go. Oh, but that's on main. Yeah, but let's take it out. So here, remove unused imports. Okay, let's go back here. So we were taking a look at Lexer. We now have the ability to skip comments. So hold on. Let me stage this. We don't need this, so let me undo this. And we have a test. Perfect. Let's commit. Feature handle single line comments, because I think we also need to support those kinds of comments here. So that's why I'm calling this that. There we go. So now we have on main, we have the command line execution, and so we compile. So feature compile file from provided from command line argument. It's fine. There we go. We don't have to do that, nor samples. Okay, let's push this. Actually, let me create a branch. So, okay, check out, how do we call this? Episode 4, I guess this one is. Let me add git remote, add Cody, git. So people that are, since we have a lot of other episodes before this one, I don't want to push it to master. So I'm going to push it to my personal repo. So it's going to be fcody EP.4. vi git config. I forgot the .com. Let's try it again. There we go. All right, and I actually think I'm gonna call this episode here. I think the length is like more than 1 hour. And next time we're gonna pick it up from here, and we're gonna start. Let me see what we're gonna do next episode. Oh yeah, we're gonna do the addition of the test suite where we can make sure that we don't we don't add any regression to our compiler. And then once that's done, what I really wanted to do is if we go to samples basic, I wanted to start supporting binary operators like 2 plus 1. So that's what I think where we're going to start on the next episode. All right. Thank you again for watching, and I'll see you on the next one. Bye-bye.